Hey everyone, welcome back to Inventing Construction. I'm Ross Griffin, and today we have a very interesting guest. We're sitting here in Copenhagen, and Christian Kongsgaard. Kongsgaard. That's my Danish for you now, I'm afraid. Yeah. Kongsgaard is here with us. We're going to discuss, can we code our way to a sustainable future, which is kind of what Christian is doing at the moment. And our subtopics are, what is LCAx? That's Christian's company. And how does he see coding helping us in the future? What are the next big areas of development? And then advice for you guys out there if you're looking to get into this. Christian, perhaps you might introduce yourself rather than me trying to.
I think if you want to do the English pronunciation, then it's Kongsgaard.
Kongsgaard, yes.
Yeah, that's a bit easier to make it sound like that. I have my own company. I'm doing software consultancy, but I have a background as a architectural engineer, actually. Okay. Studied that, and during my studies got introduced to in the beginning, first like Grasshopper and this visual programming thing, and then slowly into to proper software. Yeah. And then I got a software job, and it kind of rolled in that direction since my graduation.
I was curious about that. Is it accidental that you happen, if you're an architect, for example, is it that accidental that you fell into software development, or how did all that happen?
Kind of, but like it was of course driven by interest. Yeah. We at the university, we quite early on got introduced to Rhino and to Grasshopper. Right. One of the first semesters, and I thought it was fun. Yeah. And then maybe a semester later, I got I found out this thing called Ladybug. Yeah. Which was, for those who don't know it, but it is like an environmental plugin. You can do sun studies and stuff. And this is back in like 2012, 13, something like that. Yeah, yeah. And the tool was quite new, Ladybug, and there was a lot of bugs. Yeah. And I got it annoyed me a bit, and then you could fix them. Yeah. And these guys, they were on the forum, and you could write them, hey, this doesn't work, and then they send something back to you. Yeah. And then of course you have to wait for them to reply. It takes maybe 2 days or whenever they are free, right? So if you're stressed and you have a deadline, it has to work right away. So you have to learn to fix it yourself. Yeah. So I thought like how to do that. Okay. I will take a class. I took a class or like a course. We spent some of my elective points on taking a Python class. Okay. Basically just to understand Grasshopper better and to be able to at least understand why the things were, why did it turn red, right? Yeah, yeah. And then so you could actually also a bit explain it better to Mustafa and Chris who made the plugin back then. And then it's kind of, rolled. You get more and more into it. I took some more classes. I found out at some point that actually what the Ladybug guys did, which is really interesting, actually, is they took one program, and then they took Grasshopper, and then they merged them. Yeah. And they could only merge them because they could code. Yeah. And that concept of taking two different programs that had nothing to do with each other, and then merge them, and then create something more. Yeah. Like, in principle, 1 plus 1 doesn't give 2, but it gives 3. Yeah. Right? Yeah. So that concept really intrigued me, and that was something I tried to investigate a little bit in my master thesis. Yeah. That kind of concept of enhancing things, because what you learn in the university is very much, we have all this theory, and it's great, but we only have this program, and we can't do all the theory because that's not implemented in the program. Yeah. So you have to do this, and that's engineering, right? Yeah. You use this program, that's engineering. Yeah. And that's But if you can code and you can combine this program, actually all that theory and everything that's kind of possible, kind of physics-wise, you can kind of attempt at making, if you can combine things, or you can make your own.
Super interesting that you're able to, if you're studying engineering, you're also able to have the opportunity maybe to digress a little and focus on certain areas that might not necessarily be traditional engineering. Mm-hmm. Yeah. And maybe dig into that to see if the interest you have is something you want to do. Yeah. I can see that a lot of educational courses are quite narrow in that you have to stay in your swim lane. You can't go left or right. You have to stay in here, and at the end result, you get that certificate. But if you are studying engineering or architecture, you kind of need to be able to understand these other components.
You have to have the kind of the understanding of the whole, right?
But Christian, so can you tell us a little bit about LCAx then? Yeah. What is this LCAx?
First of all, LCAx it's not my company, but it's a project that I have, an open source project that I started together with some other guys last spring-ish. Yeah. The core is like an exchange format, so this is basically a data structure for exchanging LCAs, like lifecycle assessments, right? Between different programs.
Would that be like IFC in terms of that common language in order to be able to share between programs?
Yeah, I think you can think about it a bit kind of in parallel to IFC, right? It kind of tries to solve some of the same issues. But the idea came because here in Denmark, the 1st of January 23, there came this new regulation that all new hand in your building permit, you also have to hand in the LCA, right? And that led to that a lot of programs started to come up, like to calculate your LCA, because people need to make the LCA, right? Yeah. So then suddenly, instead of having this one program that was kind of mandated by the state, or like LCA book, then you suddenly start to see like 3, 5, 10 programs that is actually applicable to the Danish market. And then you start to wonder, okay, so what happens if I do in this program or in this other program? What happens if I'm the building owner and I have an architect competition? Yeah. We have 5 entries. Yeah, 5 different programs. 5 different programs. Why do they have 10 in the result? Why 8.8? Yeah, okay. And it's not standardized. Like there's some EN norms that regulate how you should calculate, but it's not very concrete. Like that's what we've noticed. It's up for interpretation.
Yeah, right? Absolutely. Yeah.
So we just in the beginning the idea was just let's take these kind of the output from the different programs and make it to the common format. Yeah. So then you can compare saying this kind of, if you take the architectural entry example again, then they have 10 because they have more facade than these guys.
And 10 CO2 per square meter over the 50-year life cycle or whatever.
It's different, right? Or like in more extreme cases, like these guys, they forgot the foundation in the calculation, right? Yeah. Or whatever, these have twice as many windows. Yeah.
It's really interesting that you talk about LCA in that way, because we approach cost as cost managers, quantity surveyors in the same sense. So transparency in the information is key. And we always talk about, for the client, preparing a bill of quantities and giving that Tibusliste and giving that to the contractors, all of the contractors that are competing. So you standardize the information structure so that when they're pricing it, you have like for like prices coming back so you can analyze. And what I'm seeing on the LCA now, especially when we have this discussion in Denmark, is LCA is now forcing us to prepare documentation or prepare standards before we go to competition or procure. So we have this ability to analyze and see the gaps. Did architect B leave out the foundations? Did contractor C calculate the facade correctly, or so on? So it's super interesting that they're it's very similar in that conversation, LCA and cost from our perspective.
But I think actually like one of the, like this whole kind of push for sustainability in general in the building industry actually has some kind of very interesting side effects on how we digitalize it's forcing us to digitalize much more. And right now it's pushed by the sustainability, but there's a whole lot of other applications
100%.
that benefit from also cost, right?
Yeah.
So because if you can kind of lift the kind of level of of 3D models, basically, right?
Yeah, yeah.
Then you can start to harvest all kinds of different information, and you you make that a higher data quality in principle, exactly. And then you do more interesting things, and it's like there's a whole like line of applications you can do. Right?
Yeah, and of value for other stakeholders. It's one of the big things we talk about in that value of building information modeling or 3D modeling is that if you use the model and you develop good quality in your models, many other stakeholders can then use that information. You're not producing that information again. And we see it in some other markets, like in Ireland. It was the same in Denmark 15 years ago, where there's a 3D model that's okay, it's used for drawings, but when the contractor takes it over, they remodel everything again and start from scratch. Now that's happening in Ireland today, but in Denmark, I think we have transitioned through that period now, and we're into good quality 3D models at design stage where that can be used by the other stakeholder groups. That for sure offers a huge amount of value to projects.
Yeah,
definitely. So LCAx then is a open source common language for sustainability.
Like it's in principle just for exchanging the files. Like that is kind of the base, right?
Yeah.
And then what I wanted to do is then to extend it a little bit more, because I don't know if you know this comic, but there's this very famous comic where there's two guys saying something like there's 13 competing standards out there. Yeah. Let's make one more that will rule everything, right?
Yeah, yeah.
And then some pictures later, then now there's 14, right? So instead of trying to make that number 14 standard, I wanted to make sure that it's possible to convert, right? There's also a little bit in the kind of the idea that you should take and compare, then you have to convert from other formats into yours, right?
Yeah.
So it's not trying to kind of impose or replace other formats, but rather this conversion. Yeah. So that's the data structure, and then there's the conversion kind of functionality, which is kind of the second pillar of the tool, which of course I'm trying to develop further. But like the idea is that is really also a place for kind of the community or third parties can come in and saying, I have whatever format, I'll make a converter to LCAx and back, right? And then the third pillar is validation. Yeah. So if you have again a bit maybe back to the idea or the example of this architectural competition. So one thing is, you can go in and see, okay, this guy has more wall and this guy didn't have a foundation, right? Yeah. You can like visually inspect it. Yeah. But what you really want to do is do it automatically. Yeah. Right. Yeah. Exactly. So the idea is to have a validation engine. Yeah. That you first of all, because of the schema way it's built, you validate that the values are there. Yeah. Like you didn't put a piece of text where there should have been number, all these kind of basic things. But also that you can apply different rules to it on top, like user-defined rules, saying, I want all my EPDs to be of a certain standard, and then it checks all the EPDs in there. Or I want to make sure that everything in my file is classified with this classification scheme, right? So like doing automatic checks like that and being able to extend that, that's kind of the third pillar. And then the final and fourth pillar is that when you have all this information, sometimes you don't have the results. Maybe you didn't get it from LCA Byg, or you didn't get it from some other provider, but you did it like out of your Revit model. Some export format. Then you want to be able to calculate it. So you have all the information.
All the information, but you don't have the result.
So basically, you make a little bit like a small engine that kind of sums and multiplies everything together, and then you get a result. Yeah. It's a quite easy build upon. And then you have these four pillars, then you can then construct into something new. Like everybody are able to use those pieces to build something, right?
I think the biggest challenge that we have when we bring in software and automation is the validation of good quality data. Mm-hmm. For example, you mentioned the EPDs there. Do we have enough good quality EPDs to allow us to calculate or carbon. Well, that's a global problem. That's not localized to any country or anything. Because we've just started the journey on sustainability, we're not there yet because I guess as an industry, we haven't produced EPDs in volumes yet. We don't have an EPD for every single product. No. So really what we're trying to do is calculate to the best available information we have right now and then validate the quality of that information to see, is it high quality, medium quality, low quality?
Yeah, and you can put some checks. Is it like a specific product EPD? Yeah. Is it like industry standard? Yeah. Is it like a general?
A budget EPD or whatever.
Right. Yeah. So, I think that should also be something that you can kind of validate and like it should be visible like that. I think one of the things that really, if you need to drive this sustainability transition, you have to be transparent about all these things because, as you say, there's not EPDs for everything, but at least you can kind of disclose, okay, I use this one. Yeah. Like that's the best data we have, so I used it, right? And it should be hidden.
It's another contrast now that I see happening between LCA and cost. LCA is driving more transparency and visibility of the data. Where did you get your calculation for the walls, for example? Or it came from this EPD. What is that EPD first from this assembly type, for example, not just product, assembly type. And from a cost perspective, we're constantly advising our clients that's the transparency you need from economy as well, so that you can manage change later. Because change in the wall type, change in the quantities affects your carbon calculation, but affects your costs. So if you can run both, I get outputs with the same level of transparency, you're in a very good position on projects. Now that's very new for a lot of companies, clients, developers, communas. Having transparency in economy to that level of granularity is challenging for them. And we can see that from when we go to carbon calculations, that it's becoming difficult for people to understand what level of granularity do they need to go to. I'll give you an example. Do I need to go as far as the gipsplella, the gypsum board, or is the assembly of the stud partition or the gipsvägge enough in terms of that granularity? I would say at a client level, it's the wall itself, the assembly, not the material type. But for the specialist contractor or subcontractor, that gypsum board is important because that's part of their delivery. So the granularity depends on where you sit. I would say in the stakeholder group.
But I think that kind of concept applies to many things, right? Yeah. That you need to be able to abstract to the level of kind of who is receiving it, right? Yeah. So that's also, I think, we just touched about the classification schemes, but like there's a lot of classification schemes out, but they all apply to different either professions or stages in the building process, right? And just because people need to group it in different ways.
Another thing I can see happening is that because a lot of clients and developers and investors out there we're not understanding carbon and how we manage it yet, a lot of people are expecting EPDs right at the very beginning, right at concept design stage. We need EPDs for everything. And we're saying as cost consultants, you don't need an EPD. You need to set a carbon budget and then manage the EPDs as they come in against your budget. Is like cost, as cost managers, we set a budget for the stud partition, the gipsvägge.
Yeah.
We believe it to be X krona, X euro per square meter. The same principle applies for carbon. We believe it to be X CO2 per square meter, for example, for that wall. And then as you're procuring the project from the contractor, from the supply chain, then you apply your EPD to that and say, am I on budget? Am I over budget? So it becomes a management and change management process through the project life cycle. Not a requirement to have the exact EPD from the supplier, because how am I to know what supplier the contractor goes for as a cost manager? It's impossible.
Exactly. But I think in that way, cost and CO2 are really the same thing. Or like, because it's kind of it is a cost, or like
it is exactly
put a currency.
It's a currency,
right? And it's what is interesting also, like about CO2 is that you used to only have cost.
Yeah.
Now you also have CO2, right? And you have to balance those two things. But kind of the idea that you have a budget in both, I guess, and you have to manage them in the same way, right?
Yeah, exactly. But it's super interesting. So LCAx is open source. You like when people get involved in it and start asking questions, of course, and the challenges, like historically with Ladybug when you were in university, the same principle applies, right?
Yeah, sure. We try to, I think also I write it in the documentation that it is not like a finished format. Like it's basically a draft of what I think it should be right now. Yeah. And if you have other ideas, like we invite you to say what feels amazing, right? Or what should be changed. So in that way, it should also grow in the future because involved with with time and people use it and the different use cases. Yeah. So we try to make it flexible enough that you can also, because you might not want to encapsulate everything. You don't want to be able to do everything. You want to have some kind of scope on it, but you want to be able for people to extend it in certain ways that only applies to them while still keeping kind of the integrity of the whole thing going forward. Yeah. So you can have mini branches.
Exactly. Keep the spine of it is kind of structured and fixed, and then people can go whichever direction they want to take it in to see how it evolves in the future.
Yeah, exactly. So in that way, it works, and as many other open source projects that kind of invite people also to report bugs and come with feature requests and so on.
So tell me, in relation to sustainability in the future, how do you see coding helping with sustainability? Coming from your background in education, kind of taking a right-hand turn into coding here, how do you see that improving or assisting the industry in the future? Will it become more digital?
I think the thing about sustainability is that it adds another layer of complexity or another layer of data on top of our already heavy data-heavy buildings, right? There's a lot of information around buildings, and this is just another thing that architects, engineers have to manage. And the most efficient way to do it, at least we have a quite short time span to get this right in. Yeah. And you have to crunch a lot of data through and compare and have your, to get your budgets on point. Yeah. That is best or most easily done by having some kind of digital proficiency. And I think if you can only do Excel, you will hit a wall pretty fast. So that's why at least have a little bit of knowledge about code would help you with some of these data heavy new tasks that's coming.
And I think that's a very good point in relation to Excel. While it's a brilliant tool, there's limitations to it, especially on some of the huge projects that are being developed today that are so big that Excel it doesn't really work in terms of that database, data structure, processing of information, because that's not what it is at the end of the day.
No. Yeah, people Excel is a Swiss Army knife, right? Yeah. But people also make a kind of a car out of it, right? And it's maybe you should have done something.
Yeah, exactly.
It is a Swiss Army knife, but keep it to the Swiss Army knife. Yeah. Don't try to make it.
Yeah, we've come across that problem in the past, but I think what's interesting about Excel is that it allows you the ability to test a theory. So, for example, rather than using one of the sustainability platforms to calculate your CO2, what we've done in Cosmos is we've calculated with an Excel. So we understand the process of calculation. We understand how we would work with EPDs. So then when we are applying and using a digital platform to do it, we understand that process. So it allows you to be able to process a certain level of information to understand the process. But from there, if it gets too big, it gets too complicated. And then, Excel is wonderful for human error, accidentally putting in the wrong calculation somewhere, or multi-users, it's not very good for
No. Yeah, and it, as you say, it hides errors very well because you can't really see.
Yeah.
And like it's hard to check. And like I don't know, if you have 2,000 rows of data that is, and you have 100 columns.
Yeah.
Like who is going to go through and see if you put the decimal points?
Yeah.
1 or 2 points to the left or right? So
that's
like some of these things that you should use the tool for.
A very good one that not many people know, but we've come across is the decimal point versus the comma when it comes to currencies. So in Denmark, 1,000 is 1.000. Ireland, the UK, it's 1,000. So depending on who your client is and how you're reporting, it's either a comma or a decimal point. We've come across some beautiful challenges when doing that, I must say.
It is even worse if you have CSV files.
Yeah.
People have like a tendency to want to export to CSV because that's basic and like universal and everything, right? And then you try to load it, and then you have to figure out if it was a comma or a dot, or if like actually the columns are separated by a comma, or that comma actually belongs to the decimal separator. It's like it's a total nightmare.
There's one other area where I think coding is super important for us, is that as our industry is growing, and you can look in any country, it's growing, and the need for skilled personnel is also growing. Yet we're not producing enough skilled personnel coming out of universities going into the construction industry. So the way we look at it from a quantity surveying cost perspective is that we need to do more with less. What I mean by that is that our team need to be able to do more with the numbers that we have. And the only way to do that is digitization, is coding, it's softwares, it's standardization. So you're removing all the manual tasks, like you mentioned, checking Excel 100 rows and 2,000 lines, that's impossible.
Yeah, like in some way that it's really like a efficiency problem, right? You have to do something completely new, but you don't have the time to train a lot of people to do it. So you have to automate it.
Going back to the cartoon analogy where the two guys are pushing the cart with the square wheels, and the guy has the wheel and he say, look, just change it out. No, we don't have time. We're too busy, that analogy. But working with coding, then working with the kind of digitization, where do you see the next big area of development? It could be in sustainability, but in construction in general, where would you see the next big area of development?
I think one of the kind of urgent development that I think it's coming quite fast is the whole kind of the discussion around biodiversity. And it's really like circularity, like this biodiversity. Like now we're talking about LCA, and I think in a few, like they're already talking about biodiversity is coming really fast. And we have to transition to that even faster than we did to LCA, because like suddenly we have to include that as well. So that I think that is like the first thing that is coming in that direction. But then circularity, and that's like I think that's a whole different beast too, because right now everything we do is basically linear. Right? And it has some nice. It makes it easy because then you just hand it off to the next one, and like you forget what the last guy did.
Exactly.
And that make processes easy. But if you have to,
the responsibility is not there either. You hand it over now. That's I've
done
my job.
The contracts.
I've done my job.
Yeah, right. But if you start to have to do this circularity thing, I think you have to think about things in a whole different way, and you have to make structures that are totally different. And suddenly, I think maybe what is the most challenging thing is that, your building has to, or your building components have to live for whatever 50, 100 years, but your data also have to do that.
Yeah, exactly.
And we are still like kind of in the infancy of data, and like, should you use text files, should you XML, JSON, all these things, they're popping up, but we don't really have, like we're almost at a track record of 50 years with digital information. But so we have to double that, right? If we have to capture some of these building components.
And the reality of it is that I think the technology, the softwares, the programs, they're all there already. I think it's our inability to connect all the dots, linear, and then connect it circular and go, this is the process. And I think we're struggling with that as an industry because of that traditional linear handover responsibility, step back, I've my job done, I'm not on the project anymore. Obviously, I've nothing to do with that. Whereas I always relate it back to a pearl, like clothing, where you buy your t-shirt, you buy your jeans, you don't know where it's come from, you don't know who's manufactured, you don't know anything about it. And then suddenly it's yours, but it's not yours, it's disposable. I can wear it once.
Yeah.
And that all needs to change, including in the built environment, right? But that mindset change, that's a huge society shift from what we know today. Yeah. And that's probably a generational thing. Like we're not going to do that we're not going to do it in the next 5 years anyway. No.
And I think maybe what makes it even more challenging is that you don't just step on the next thing. Like the next step.
Yeah.
Like you have to do it gradually. So all your solutions, they have to be adapting to both be able to do the full thing, but also kind of nothing, right?
Yeah.
So you have to have all these middle solutions in between. That is
absolutely
half right, right? And when you have to make a circle, and
how does that all work together?
And I think it's a big challenge.
Some of it is the application. Other side, I think, is policy as well. We need to change policy, and I like now the idea of ESG. If we can get away from the fluff, and the greenwashing around it, but if we can really get down to strategic reporting on ESG, it's pushing the responsibility back on everybody to look at their supply chain, even including the individuals like me and you when we purchase things.
Yeah.
And I think it's one of the biggest shifts, I think, in our industry in the last 50, 60, 100 years, perhaps. The Industrial Revolution, maybe. For people out there that are interested in LCAx, coding, sustainability, what kind of advice would you have for them then if you had to reflect back on your...
Like when people ask me, like, how do I get started with coding? I always say that, of course, you should start and don't put your ambitions too high.
Yeah.
But what I think, like, always do like something practical.
Yeah.
Or like have a project that you can do, because you can take courses and there's a million good courses.
And free online as well. Right?
Online courses you can take. But if you just take a course and it takes 10 hours.
Yeah.
Do you really know how to code afterwards?
Yeah.
Like I think it's super useful to actually have a project.
Yeah.
And I tend to recommend people to learn to code and make your own website.
Yeah.
Because it makes it easy. You can make a website. You can like make a portfolio where you have some projects. You can put pictures up and so on, and you suddenly have something practical, something you can show your mom, like all these all these things, right?
No.
Or like if you are more like the engineering type, like try to do what you did in Excel in Python, right? So kind of Swift that.
Yeah.
But like have something practical that you can tinker with.
And I think that's a very important point. We often look at the universities and the educational system and a lot of the time it's project-based, and project-based is where you get to work with people and you become that, where you can apply the practical and the theoretical, the theoretical education in a practical sense. Whereas a lot of education is single, as in I do my work myself, I need to learn this information, I need to apply that to an exam at the end. And the reality is that's not how life works on the construction site. In business or in industry, you don't learn something off and then go in that evening and then go to work the next day and try to apply it.
No.
It's the ability to be able to understand what it is you're learning and apply it in that group environment.
Yeah, and you kind of iterate on it, right?
Yeah.
You maybe watch an hour of video, and then you improve your website, and then you watch the next hour, and then you improve, and that applies to many things, right?
Yeah. And I think the integration with software development, coding, and the traditional specializations like architecture, engineering, like quantity surveying, cost management, there needs to be that kind of integration, because what we see coming out of university now with the cost managers and quantity surveyors is there's not enough of the digital education in it. They're not learning coding. Even advanced Excel is something we're always promoting. We use it every day in our specialization, yet we're not even being taught it in university. You have to self-learn that stuff, and that's not good enough in reality. So our curriculums in universities now need to change to become more understanding to what the future will hold, which is it's inevitability. It is coding, it is the digitization, etc. So I guess the advice to young people out there listening is that start investigating this. YouTube, for example.
Yeah. YouTube or some of the free online courses out there. I think it's also important to say that it's not like if you can't code, you can't get a job in the future. Yeah. It is for some people.
Yeah.
But it's not like everybody needs to be able to code. But like I think definitely if you want to take a path down the engineering specialist direction.
Yeah.
Then at least some understanding of how processing data, how that works, whether it's being Excel or it's actually code.
Yeah.
But like how you kind of process data is really helpful, right?
And I would say for our discipline in university, we need to have an appreciation for architecture, engineering, whether it's structural engineering or systems engineering, to be able to apply that cost and contract. So we also now need, as cost managers, QS, an appreciation for coding, so that perhaps there's something there that we can merge, or just we don't have to be the experts in it, and we're not. We just have to have that appreciation, because we can bring in people like you, Christian, who are the expert on it. Like
exactly.
Yeah,
that's definitely. There's also like knowing a little bit about many things.
Yeah,
like makes you able to tie all these pieces together, right, and get the right people on the project.
Yeah, it's super interesting. But I think where we are in our industry right now, in this moment in time, is exciting, because it's changing so much. I wouldn't have been having this conversation 10 years ago.
No,
like I wouldn't foresee myself to have this conversation now 10 years ago, and it's moving at such a pace at the moment, kind of globally. It makes it super interesting entering the industry. And I think that's maybe one of the target, kind of the marketing we could do for our industry, is that construction traditionally is a hard hat and boots digging a hole. But the reality is that there's a whole other aspect to the industry now, which is more of the data structure, data information management, etc., that could be super exciting for people.
Yeah, I totally agree.
Christian, thank you very much for your time. It was a pleasure to have you on. Thanks very much for listening. There's a LinkedIn link below in the show notes. We would love to connect with you.
We hope you enjoyed it and have you with us in the next one. Thank you very much.